imagine a world 10 years down the lane where the things that we are looking as of now would change drastically. And you are true, that is because of the new discovery, fusion ignition, a laudable effort by Lawrence Livermore National Laboratory based in California, United States. We'll understand about the laboratory as well as this process of fusion ignition in a while. So let's first talk about fusion. So there are two processes. One is fission reaction when we talk about nuclear reactions. The other is fusion reaction. Under fission reaction, one bigger molecule breaks into two smaller molecules. However, under fusion, two smaller molecules combine to form a bigger molecule, and there is the release of energy. Now, in this process, deuterium plus tritium combine to form helium and release neutron, and this process is where we have the change in the effective nuclear mass. Now, so far when this nuclear fusion reactions were tried, there was a net energy loss. This is for the first time we have witnessed an energy gain, and therefore this technique has become significant. This technology has become significant because we can move forward for commercialization of fusion reactions. Now, if I talk about commercialization of fusion, that means the existing technologies get redundant, oil becomes redundant, the importance of Middle East in the world becomes reduces, and there can be future crisis for Middle East because now we have moved on to an alternate method for energy generation, and that's through fusion. So rather than looking for the alternate fuels, we should use for alternate technologies for battery, we can say. So rather than discovering hydrogen as a fuel or alcohol as a fuel, we should probably move forward and discover technologies which would be hydrogen based fuels, fuel batteries, or lithium ion based fuel batteries, because through this fusion reaction, we can directly generate electricity through which you can now run your electric cars. So this technology would definitely give a way forward to a cleaner source, a greener source, and more importantly, reduce the dependence on oil. Now, this process of fusion ignition so far was energy losing. That means whatever energy we were providing to it, in return, we were able to get only lesser amount of energy. That proves that this technology was not viable. However, by the experiments which have been done by Lawrence Livermore National Laboratory recently, we'll come to the basic understanding of how this experimentation was done. The idea is that the net energy gain has been received, and three factors which have been cited to it. First is the spherical shape. The second is the temperature, and the third is compression. Now what happens? If I talk about sun, there is where you have a classic example of fusion. Now in sun, the deuterium and the tritium, or we can say the hydrogen, is coming together. Now how hydrogen is coming together to form helium? To generate that, either we would have to put it in a container, but when we would bring that to a high temperature, that container would probably melt. So this is not practically viable solution. So what happens in the case of sun is, because of the gravity, these molecules, these atoms come together, and therefore formation of helium can take place. But when we want to do the same experiment on ground, how can we make it possible? So understand this as a glass, okay? Consider that I have a glass here, and within a glass is a very thin rod, between which is a very fine small pellet, and that pellet is the fuel. What is that fuel? That is deuterium and tritium. One of deuterium, another of tritium. Now this is bombarded with laser. Now when this is bombarded with laser, three important things that we need to take into account. First of all, this fuel has to be kept within the electromagnetic field. That means that those particles should not move outside, so they would remain within that region. One thing. The other thing is to ignite them, to bring them initially to a high temperature, we would have laser bombardments. Now this might appear a smaller thing, but in reality it is a huge setup of a size of a football stadium where huge lasers are being bombarded to that small particle, and that initially increases. So under this experiment which was recently done, it was a threshold where 2.505 megajoules of energy was provided and 3.15 megajoules of energy was obtained. That means a net gain, a positive energy or a net gain was seen. So Lawrence Livermore National Laboratory is a major research facility in Livermore in the region of California, as we have seen in this map, and this was originally established at as the University of California Radiation Laboratory, and here this was established. Why is again important, because this was to detonate the first atomic bomb which was used by Soviet Union during the Cold War. Later it became an autonomous organization in 1971, and finally in 1981 this became a national laboratory. Now as it became a national laboratory, it was funded by the federal agencies. So this ignition principle is very interesting. As we mentioned, between these two is where you have the electromagnetic field and the deuterium and the tritium which are placed, and they are then bombarded by the laser. Now this has been made possible with the efforts of Department of Energy, National Nuclear Security Administration, where the first fusion ignition took place under the laboratory which is the LLNL, the Lawrence Livermore National Laboratory, and at their NIF, which is the National Ignition Facility. Now in 2021 the same experiment was done, but the recent experiment has lesser spherical shape, still were able to produce a net positive gain. Three factors which we said are extremely important is maintaining the spherical shape during the reaction, maintaining the temperature and the compression, and then getting a net positive energy. Now as soon as a net positive energy is gained, we can say that this can be brought for commercialization, because ultimately this is a renewable source of energy. There is no waste which is generated, no greenhouse gases which are released, and the way the stars function is the same through the explosions, and this is where we have the same concept which can be applied. So in this fusion facility there are nearly 200 lasers, each of the size of 3 football grounds, which have been placed to initiate this process. So here is where this project ultimately happened. The LLNL, the Lawrence Livermore National Laboratory, and so far this laboratory has been engaged with numerous things. For example, working on nuclear weapons, plutonium research, global security programs, shale oil extraction, geothermal energy. This has also worked with hot recycled liquids, in situ extraction techniques under the RISE program, radio frequency technologies, and so on. So this agency, this laboratory is funded by US Department of Energy, managed privately and operated by the LLNL, which is the Lawrence Livermore National Security, which is a partner to University of California, along with Bechtel, BWX Technology, ICOM, Battelle Memorial Institute, along with Texas A&M University. This laboratory is also credited to discover the livermorium, which is 116th element in the periodic table, and this laboratory has been extensively involved with preventing the proliferation of nuclear weapons or weapons of mass destruction, solving nationally important problems including energy, environment, and bringing things for economic competitiveness, that is bringing things for commercial use later on. And this discovery is indeed a breakthrough discovery in science, extremely important for your upcoming examination point of view, and many such topics we'll discuss in the upcoming lectures. Don't miss. Do follow the links below for complete UPSC preparation. Wish you very good luck. Have a wonderful day ahead.